So my talk is Pardon the Noise, Excuse the Dust. It's basically about all the things we are building in Chrome. And first the question is, who is we? Says that I'm Rachel Blum. You can find me on G+ as Rachel Blum. You can find me on Twitter as Groby. You can really find me pretty much anywhere as Groby, really. And I'm a Chrome front-end engineer. And as Seth said, I used to work in video games for, 15 years. And those experiences obviously shape, why I'm doing what I'm doing and where I'm going with my career. And one of the things is the platform zoo of video games. I've worked on home computers, it's your Commodore 64, Atari, Sinclair, the BBC, you name it. I worked on Unix boxes, I worked on PCs, I worked on arcade games, I worked on console games, and I'm listing MMOs as a platform there because really, those take all of those platforms and mix them together for added fun. I fixed my last endianness bug, I hope, forever, 18 months ago. I hope at least some in the audience have no idea what I'm talking about, for your benefit. And what I always wanted for computer games was a platform that we have in the AV sector. You buy your surround sound system from one guy, your DVD player from the next guy, your TV from the third guy, you plug them all together, and the gods of HDMI willing, they actually work together. And we just don't have that for games. We have tons of different platforms. We waste time without end, just porting things from A to B, back to A, and fixing all the bugs that we just introduced, just porting things. So what I want is one platform. So that's why I ended up at Google working on HTML5. And when I say one platform, I really mean all of the browsers. This talk is going to focus mostly on Chrome, simply because that's what I'm most familiar with. I started working in earnest on browsers 6 months ago, so forgive me if I don't know the in and outs of all 5 major browsers. So I'll skip the other ones. That doesn't mean that I think them as lesser. We work together with pretty much every browser development team to make HTML5 better. It's just I'm focusing on what I know. And in terms of, what can I do with those other browsers? There's an awesome website, caniuse.com. I'm sure at least the web guys are intimately familiar with that one, because you can take any feature you could possibly think of in your browser and ask that website, hey, what's supported? So if you look, for example, at WebGL, you see it up to 3 revisions back. You see near future and far future, if things are supported or not supported. So you can make your decision which platform to choose. And as I'm planning to sort of give you an overview of what's in HTML5 for games that is fairly recent, and I decided I'd start out with what I call terra firma. The things we've explored, the things where we have at least sufficient capabilities to build games. It is always in need of improvement, but it's good enough that we can actually make a game happen. So clearly there's JavaScript, right? The last couple of years have seen a performance race, really, between all the major browser vendors trying to make JavaScript better and better. And the canonical demo for games and performance is, of course, Box2D. You can do a little bit of physics and just have fun with it. And the fact that you can run a physics simulation in JavaScript is pretty impressive, at least to me. It's pretty high performance. And the other thing that matters is graphics. And yes, this is really intentionally left blank, because if this and the next demo are on the same page, it doesn't work. So WebGL, obviously, pretty shiny, works well. Let me drive this thingy around just because I can. Always wanted to drive a race car. I think looks good enough that we can actually make a game out of this one. So, that is pretty much covered. For communication, we have WebSockets. You always need, for any multiplayer game, or even if you have your own custom server, you would like to communicate with it. You don't always want the overhead of HTTP. WebSockets are low latency, they're persistent full duplex, so for many purposes they're great. They support UTF-8, which is awesome for a lot of web apps and really doesn't matter that much for games unless you happen to, have text as payload. They're super simple to use. The important thing for games is Chrome 15 now supports binary, and unreliable transport, or UDP, is being discussed for WebSocket, because if you've spent any time making games that are networked with each other, you know you need UDP for some things, because TCP sometimes hiccups a little bit. Another thing that is pretty well established is just how do we handle asset storage, asset transport. I'm going to expand a couple of slides on that, just because that's sort of what I spent the last 6 years of my life working on. How do assets get from the artist into the game, and from the game server to the end user? What do we do with that? So it's sort of near and dear to my heart. You have plenty of options for local storage of assets. I'll skip web storage and IndexedDB. They're really more important for, I think, storage of game-specific data like high scores or friends list or whatever than they are to large binary assets. The first thing is the file system API. It gives you a local sandbox storage where you can store all your assets. You can cache your resources as you see fit, so you really have full control, what gets downloaded, what is cached, what will we re-download. You can store large amounts of binary data in there. It's currently Chrome only, and again, I'm hoping that we can get this API across all browsers, because that's my goal. There is the application cache, which is a super important mechanism, because especially for smaller applications, Chrome supports, I think, 5 megs of data. You can have your entire app local on the customer's device, which, for a lot of games, you might just be able to squeeze most of it into 5 megs at least so you can play the game. And why should you do that? Well, you have assets that are hopefully fairly consistent, right? You don't push a new version of your main character every 15 minutes to the gamer. You have hopefully decided, this is the one, we ship that one. And browser caching, you really have no control over. Your browser can decide to evict the resource whenever it feels like it. It can re-download it whenever it feels like it. So that's not a good choice for games. You want more control. Obviously, your app is zippier when you load local assets. And another big thing is you have a JavaScript API to the cache. You know what's cached. And all you need is a cache manifest file, which means you add one line in your HTML, you serve it with a specific MIME type, and you have a cache manifest, which lists all the items that you would like to explicitly cache. You are able to specify fallback items, which is super important because it means if you have parts of your app cached and you are in offline mode, you can show different things to the user to just let the user know, hey, you're offline, that doesn't work right now. You can flag certain things as always fetch from the network, for example, logins. It's kind of important to have things to debug that. In Chrome, that would be about app cache internal. You can actually look at what's been cached and how large it is and all sorts of things. There's also the JavaScript console that gives you an info, what has been cached. So it's fairly easy to debug app cache. It's still a lot of work to find all your resources, scrape them, put them in there. Thankfully, there are by now tools that, at least for your static resources that you reference in your HTML5, they just scrape that and provide you with at least a starting point for a manifest. So let's go to what I like to call shiny and new. It's, obviously WebGL is not exactly really old, but shiny and new is stuff that has happened in the last, I think, 9 months or so that I consider really important for games. One is the page visibility API. You can actually find out if the user is looking at your game right now. So let's do a quick demo. Do we have any sound? Oh, there we go. So you see here, it's currently playing. It is a visible tab. I switch back to the presentation, and it's paused. I go back here, and there we go. It's working nicely and playing the video. In a game, you obviously would want to pause your game and not let it just continue when you switch to it. That's kind of mean. But it's a fairly important thing just to give this at least the last bit of polish to your game. Let me switch away from this again, and let's continue. Full screen content is really important because for a game, you want the attention of your user. You don't want additional Chrome on the side of your screen. You really want as much real estate as you can get. And yes, of course, the user can switch the machine manually into full screen, but there is a way to also give full screen control to your executable so you can actually say, this part of the game, really, this is an important experience. I want it full screen. This I don't care. Maybe it's a screen that is just a teaser for something else. So let's play this video here, and it's playing in full screen. I'm jumping back to normal, back to full screen. It's completely seamless. It's under control of JavaScript. And let's just close this thing again. So you have full control over the screen real estate if you enter full screen mode. There is a whole API that goes with it. You have the ability to request it from JavaScript. You can support this on media elements. You have CSS attributes that go with that. So it's pretty thorough support for full screen. Another super important thing for online games is obviously knowing that you're actually connected. Because you might have a lobby system, you want to show users in there, and nothing's showing up in there. And the user's just sitting there and saying, well, what happened? Thankfully, we have the online API, so you can actually find out if you're connected. So I'm currently online, obviously. I'm going to fix that real quick. And I pulled the plug, if you can see it. We're offline. The browser detects it, signals it to the user. And now I need to get this back in here. Excellent. And we should be online again. So you can actually decide what your game does when you go offline. You can pause it. You can, do anything. You just know. It's a concept that for me as a game developer from a console background is important. I want full control over my machine. I want as much as I can really get, as much as the browser lets me have. So this is an additional thing that the browser lets me have. There is request animation frame. I think pretty much every talk has mentioned it so far. So, yes, it's important. It's important for a couple of reasons. The first one is you can synchronize your animations with CSS or SVG animations, which is kind of a neat feature to have. Chrome is capping you at 60 frames per second, which is not a big deal because your monitor is doing pretty much the same for you anyways. A really important thing, if the element that you're invoking the animation on is not visible, the browser is not even going to execute it. What you're doing is you're telling the browser, I'm going to animate something. This requires the user's attention. Don't even bother if the user's not looking, which especially on mobile devices, super important, because if you have animations running even though the user doesn't see them, it's going to empty your battery like nothing. And of course, the big one, WebAudio. WebAudio is a basically low-level audio API. And in the old days, you had the MIDI files. I was really tempted to get Celine Dion on a pink, sparkly background. I skipped that. Hopefully, you're thankful for that. You had the embed tag, which really had a bunch of issues because it means you load a plugin helper, and the plugin helper might or might not be scriptable, and really not that useful. You could embed Flash, and that's still pretty much the common technique if you want to be cross-browser platform. You want to look at Sound Manager too, who sort of has a Flash fallback solution for you if you don't have WebAudio. But you also have the audio tag. There can never be enough audio solutions, obviously. And the audio tag is great, but there are a couple of issues with it. There is the codec support issue. It's right now every browser supports a slightly different set of codecs. Not even WAV files are standard across all browsers. You have latency issues with the audio tag. You have issues if you want to do sample accurate scheduling. You get occasional glitches depending on what you do. Forget about real-time processing in any form, or low-level manipulation and filtering effects, all that kind of stuff. Really not working that well with any of the audio solutions we have. So this is where WebAudio comes in, basically. And when WebAudio was originally designed, there were basically three approaches being discussed. The first one is, I just have a buffer with data, raw samples. I process those in JavaScript, and there's an API that plays that. That is kind of neat. It gives you the low-level control, but it also means you need to do all the processing in JavaScript, which, while it's fast, you could use it for other things. It's not like we have performance to spare and we just say, hey, what the heck. Another approach that was discussed was just doing the audio processing on the GPU, since pretty much everybody has them, except, no, it's not true. Not everybody has them. And also, GPUs are not really made for audio processing. Audio processing is way more suitable for processing on your CPU. Most CPUs have specialized instructions to just deal with that kind of processing. And so the approach that Chris Rogers, the guy who implemented the WebAudio API, chose for WebAudio was basically a bunch of sound processing nodes written in native code, and you connect those nodes in JavaScript, which to me is an extremely powerful approach. It allows you to do a lot of things. You can set up really complicated graphs like the one I'm showing here for your audio processing. And it is entirely sample accurate and just basically does the processing on the CPU, so you pay a fairly low performance overhead. So I'm going through a couple of the elements of that API because I assume not everybody is familiar with it yet. So the simplest one is just playing back a sound. You just create an audio context, and you pass it a buffer. You can get that with an HTML HTTP request, and just play that thing. Let's hope sound is on. Do we have sound? You can play it with a 2-second delay. There we go. Or you can go all loopy, and you'll hear that it's pretty much sample accurate. There's no glitching in there. And thank you for the audio. I think there's another demo that's currently playing. Hang on, let me go stop that one. So, much better. So there are streaming sources if you have really long audio files. I'm not going to demo that because I don't want you to sit through 3 minutes of my music taste. You really don't want that. But it's basically you have an audio node. You say, this is my source. You hook it up to the audio context. And it handles all the streaming of the data for you. You have JavaScript nodes, which is basically the first option I discussed, a low-level buffer where you just manipulate the samples, and you can do whatever you want with it. So it was obviously a powerful approach, so we chose to include it. It's just not the only approach. So I'll expose you to some sine wave. I'm sorry about that. Which is basically generated by this code. It just creates a very pure sine wave, but you can do whatever you want in there. You have this really fancy sound effect that you'd just like to generate. Go ahead, you can do it. And one of the main points is sample accurate scheduling. Just to show that, I have a little rock drum kit rhythm, very basic, but it's a great way to see that things are really sample accurate, because if you listen to rhythm, you hear very quickly if something is off. Let's do that. So, as you can see, works pretty well, which to me, I like music and rhythm games, which means great, we can now work on those games. And there are more complex nodes. There is the gain control, which basically allows you to just change the volume of an individual channel. You can combine multiple ones to get a crossfade. See, this is the thing you've been hearing the whole time. And now I'm turning it off, much better. You have filter effects, which really is, for games, a very important thing, because you do want distortion effects. You have any kind of filter you can think of. The biquad audio filter is really the basic building blocks of more complex filters. So you can string them together if you feel like it. You can build a graphic equalizer. You can basically animate the parameters to get sweep or phaser effects, whatever you want to do. You do have filter effects, so let's do this real quick. So this is just a simple low pass. Well, let's do it on the right channel too, just because. So, really any filter effect you want to hook up, you can probably achieve with that. There are a couple more nodes that are useful. I'll skip the demos for those, so I won't be here forever. There's a delay node, which you can use for chorus effects, sort of a ping-pong delay, sort of an echoey thing with it. There is the dynamic compressor, which is very important, especially if you mix multiple sound channels, because it allows you to sort of have an overall feel of a high volume without actually cranking it up too loud. And obviously important for games because you'll usually play a ton of sounds at the same time. There's the audio panner node, which basically gives you 3D positioning control for sounds. Again, games kind of important. As soon as you start a 3D game, you want to hear where your enemy is shooting from. And finally, there is the convolver node, which allows all kinds of room acoustics effects. So you can set your game in small, large rooms, in a cathedral, in a warehouse. You come up with a setting, and you can actually do that with the convolver node. I'll skip the demo there and instead go directly to a more complicated one where I take a bunch of sounds and I hook them up to simulate a Doppler effect, which, again, for games, super important, is this noise that cars make when they pass you by. And let's pick a better sound. Let's go left, right. So your user actually has audible cues on where things are in the game world. And I figured I'll give you sort of a peek behind the scenes, how do we get those features in? Because the question that I hear from my game development friends all the time is like, you're working on Chrome, why is it not done yet? And the answer is, well, it's complicated. So in 2008, Chris Rogers decided to start on WebAudio because it was something that was sorely missing. He wrote a very early prototype based on OpenAL. It was back then in O3D, which is sort of the precursor of WebGL. It had a JavaScript API. It just allowed Chris to sort of explore things in terms of the audio space. And in 2009, he finally got the time to really work on this, work on the API design. He looked at OpenAL, said, what are the limitations of OpenAL? What do we need to work around? What would be a great design that works in the web? He also got to write a bunch of DSP code, which I assume was the most interesting part of that. I have to ask him about it. And it was all back then an O3D plugin, native code, through the NP API, so that was lots of fun to debug. And then in September 2009, he started looking into actually integrating that with WebKit, giving it proper JavaScript bindings. And he came up with the first demo where he just took Box 2D, super popular, as I said, for any kind of demo, and hooked it up with sounds on contact, and then actually went to somebody he knew at Apple and just showed it to them. The Apple part here is important because it's WebKit. Chrome and Safari are sharing WebKit. So clearly, if we want any major changes in WebKit, we need to get Apple on board because it influences their browser. And he started working on a little bit more design work. He started working on audio codecs to support different audio formats. And then in December, he was still working on the design, and he got the first formal meeting with the WebKit team. So that took quite a while, but again, it's a large team. Getting people actually together is not that easy. He showed what he had to the WebKit team, and the WebKit team said, you know what, this looks really cool. You should work on that. And so he continued working on that. And we're now in 2010 already. And Chris is starting to try to integrate his code into WebKit. Now, WebKit has very strict review policies, like Chrome has, and those policies are there for a good reason. It's basically, it is 3 major browser platforms, iOS, OS X, and Chromium. So getting code in there is not always easy. And in fact, after initial attempts to just get it in there, the decision was made that the WebAudio work should happen on a private branch, basically, for Chris. Now, WebKit has several hundred contributors, which means commits, even though they go through an extensive review process, are coming in fast and furious. So it's basically he spent the next couple of months of his life just integrating from the fire hose, which must have been tremendous fun. So in May 2010, he heard that there is a W3C audio incubator thing. And that was actually started by Mozilla because at that time they were looking into their audio data API, and they wanted to propose it to the W3C. And so Apple and Google decided to join that group too, because obviously there's a shared interest between all 3 to get a decent audio platform. And at that point, a ton of meetings and conference calls and email exchanges ensued because you now have 3 major browser vendors trying to coordinate what actually makes a good audio API. And partially as a result of that, there was a lot of redesign and refactor, just incorporating good ideas from all sides. And as a result of that, Chris finally got the approval to merge back into the main branch. Apple said, yep, looks good to us. Let's merge it back. Now, looks good to us doesn't mean that you can just push the button and you merge it and it's in WebKit. You still go through the review process. And pretty much the rest of 2010, so that's 3 months, Chris spent merging things into WebKit. In early 2011, it's a huge milestone. We got an actual W3C audio group, which is sort of 1 step closer to a standard, 1 step beyond the audio incubator. And we shipped WebAudio for the Mac behind a flag on Chrome 10, which, again, huge milestone forward because it's finally in user hands. They can try it out. And by the way, I encourage you to occasionally hop to About flags in Chrome if you don't do that and see what goodies are behind there. Because A, you get an idea where we're heading, and B, it would be kind of nice to get your feedback to see if we're doing the right thing. And then lots of porting work, obviously. And finally, in Chrome 12, Windows and Linux behind a flag. So we now have all 3 platforms. With WebAudio, users are trying it out. Dynamo ships Plink and Tonecraft, 2 really awesome demos for usage of WebAudio. I'll skip those for now, though. In late 2011, in September, Chrome 14 came out, and WebAudio is enabled by default, which is basically the final step. That means 200 million users are now exposed to that code, and it is usable if your game happens to target Chrome. But 200 million users is not too shabby. I know you want the other browsers too, and browser vendors are talking, just not yet. In October, there's AudioJetted, which is more or less a sample editor completely on the web. It's a super cool concept. I really encourage you to check it out. And this is the biggest one. Apple enabled WebAudio in the Safari nightlies. Now, that doesn't mean any guarantee that it will show up in Safari, but it's a strong indicator that Apple is considering including WebAudio in an upcoming Safari release. And for more, you really have to ask Apple, but I sure hope that fairly soon you'll have Safari with WebAudio too. So here's the question, what can you do about all those things? Because I'm sure there are features that I haven't even mentioned that you really desperately want for this game or your next game, or that you just think would be really cool. And there are a bunch of things you can do. You could participate in W3C groups or write your own browser code. I assume all of you have better things to do, like, I don't know, ship the next game maybe and make some money off it. So the next best option, I mean, not to discourage you, if you want to write code and talk to the W3C, by all means. Also, if you want to make that your living, you should probably maybe talk to Google. We always like having people on board. But the other one is file bugs, just on crbugs.com, and see what feedback you get. And most importantly, talk to developer relations. It's Google developer relations, especially the people who focus on games, really want to make games on the web happen. This is the one thing that they're pushing for because it's super important to have this platform. So if you need a feature, talking to developer relations is a good way to just signal, hey, there's interest in this. And I'm mentioning this outside of the bug tracker because, just for reference, Chrome right now has 30,000 open bugs. So if you file another bug, I promise you it's going to get looked at fairly soon. We triage all new incoming bugs. But it might end up in the, sure, we'll look at it because nobody made serious noise about it. If you talk to a developer relations person, they become your advocate. They'll actually talk to the Chrome team and say, this is super important, and we actually heard this from multiple game developers, and how about it? So please, if there's anything you need, talk to developer relations. I really can't stress that enough. There are a couple new features that are sort of in progress. They have getting there soonish, that I consider super important to games too. First one is mouse lock. We all want mouse lock. Because you play Quake 3 and you waving your mouse around and clicking everywhere, and suddenly you accidentally clicked in your IRC client and the window goes away and you lose, and it's a terrible event as a player. You don't want that to happen. Again, there is a working group that's working on it. There's a draft spec. You can follow those, or if you want to take it a little bit easier, just go to the Chrome bug report, star this specific bug I mentioned there, and whenever somebody posts something there, you'll get a notification. You'll know when there's progress on mouse lock. In the meantime, we do have mouse lock as an API for Pepper plugins that goes with a native client. I encourage you to check out native client and Pepper if you want to sort of try out newish features, because we can often push new features in there before we are through all the standardization work and cooperation and whatnot that are required to land it as actual part of the JavaScript bindings. And I mentioned here the start date, which was February this year. I'll come back to that. It's one thing you need to know about mouse lock is that we support synthetic events. And the question is, what are those and why do I need them? It's basically you can lock your mouse and then show your own custom cursor and you're moving it around and you're clicking on things, but you've completely taken over the mouse. So your browser doesn't really generate the proper events. You might use a different coordinate system or whatever it is. And synthetic events allow you to basically take a mouse event and transform it into your own mouse event and still dispatch it to the DOM, which means you can build your entire UI still completely as HTML5 overlaid over your game, and you can forward your mouse clicks to there so the UI still works. So February 2011, it's mouse lock. What the heck? I mean, that can't possibly take that long. Typical developer estimate for any task takes me about an afternoon, maybe a weekend. And obviously, this is, 9 months now? It's a little bit longer than a weekend. I mean, I wish I had weekends like that. But so the first thing is the time to first draft was actually June 2011. Not because we ignore things, because, again, there's a huge volume of things coming that we want to implement. And that's just when it caught attention. I wouldn't be surprised if that's the result of some of you talking to developer relations and saying, what the heck, we really need mouse lock. There's, of course, the usual, W3C specifications, discussions going on. You need to coordinate with WebKit to get things in there, so that takes some time. There are security implications when we look into this. What happens if somebody sort of hijacks your mouse? How do we deal with this? What do we show the user? What is the experience for the user in that case? And there goes a whole UI for permissions and whatnot with it. And all those things take time too. They don't just happen by themselves. So that is part of the reason why things take longer than you would expect. I mean, we also all know that when a developer says it's going to be a weekend, it's probably going to be 2 weeks. But those are additional things that influence that. The joystick API, we're talking games. I mean, seriously, we still don't have a joystick API. There is a draft spec. It's being worked on. And, the Mozilla guys actually have a working implementation. So if you want to try that and play with it and get a feeling for it, go hop over to Mozilla, get a nightly build. It's super easy. You just hook it up to your animation callback. You get all the game paths. You query the buttons. And there you are. WebRTC. It's something that I think is really important. So what the heck is WebRTC? The official definition is a plugin-free, high-quality, real-time voice video communication in the browser, or as game players know it, team chat. It's, you have a complete engine in the browser that takes care of all the nasty things like, taking out the echo if you're actually talking while you're getting some commands from your teammates, noise reduction, gain control, network jitter management, all the nasty stuff. It has a bunch of web APIs for audio and video capture, for playback, for device management. It builds on the peer connection API, and it basically will allow you to build a communication system in your game right in your browser without having to deal with all the low-level issues. Here's a nice architecture diagram. The only reason why I'm showing this diagram, except to say it's a really cool diagram, is if you look on the right-hand side, the network I/O stack, that is a peer-to-peer connectionless stack. This is something that I think we really need for games. So it might be a good idea to maybe lobby to get that exposed. I'm just throwing that out there. There is a draft spec. Of course, there's a draft spec for everything. WebRTC is an entirely open source effort. It's royalty-free under the BSD license, so if you happen to make games that are still native code, sure, go ahead, grab WebRTC, and you have your team chat in there too. And we have fairly cross-platform support. It's right now Google, Mozilla, and Opera. And again, we're hoping to make this a HTML5 wide standard. And finally, it's terra incognita. The things that we need, but we don't even know we need them, or we can't really clearly see them. It's sort of the mysterious future. And there's a bunch of stuff that's missing. There's orientation lock on basically any phone device, because you don't want your game to flip orientation every single time the user accidentally tilts it too much. It's, from a user perspective, the most annoying thing that happens to you on games. You want hardware feature detect. I mean, people want to know what's the CPU performance on this thing, what's the GPU performance, how much RAM do I have, what's the display DPI. And this is another one where you say, well, it should be super easy. Yes, it should be super easy, except it has huge privacy implications. If I get a full footprint of what your hardware is like, I have a good chance of actually identifying you across different sessions of different games. And we're fairly concerned with privacy, so we're trying to come up with a way that prevents that, that doesn't allow you to fingerprint users, but still gives you the ability to find out, can I actually even run this game on this machine? You want high performance timers. Obviously, games are kind of all about timing. They're sort of being looked at in the meantime. I haven't tried it out yet. That's sort of on my play with it list, but the WebAudio context has a really cool high resolution timer. You might want to borrow that until there are real high performance timers. And there are many other things. There are in-app bug reports. It would be really nice if your users could just click a button and say, there's a bug in this application, and it goes straight to you. So that's something that's being looked at. There are way more things that are outside the scope of really the browser, but that I really think still need to happen for games. We can talk about monetization and downloadable content and social features and leaderboards and whatnot. All this still needs to happen. On the browser side, I think we still need better control over the asset management. I alluded to that in the beginning. It would be super nice if we got, in general, a better development environment. Chrome has some development tools built in. There are other development tools that should go in there. Again, if there's some that you're missing, you should mention it so we can actually work on that. And really, a ton more features. I'm sure every single one of you has at least 2 or 3 features that they're thinking of right now, and they're saying, well, why the heck didn't she mention my feature? It's probably because I don't know it's there, or because it's being worked on and I'm sort of running out of slides. And really, we're building the future with HTML5. This is my dream. We have a common platform across all kinds of hardware. You have a giant user base. Chrome alone is 200 million. Lots of things go into Safari from there. And if they become a standard, you talk billions of people. They all follow the same standard, and your game can reach them. And I think building that is an enormous opportunity. And this is why I joined Google, and I hope you help building that experience. Thank you. And we're sort of out of time, but we're not, since I started early.
I got a couple questions. One is actually just that the joystick APIs are not actually in the Mozilla Nightlies quite yet, but there are special builds if folks want to get them.
Okay.
And then a question for you. You had mentioned that you didn't think IndexedDB was suitable for putting large binary assets in, and I'd be curious to understand more about that.
Let me phrase it differently. You can put it in there. I think it's overkill for it. You don't need a transactional database to actually get your game data. Or at least I happen to think you don't need to. You can certainly put them in there. Nothing's keeping you from doing that.
I mean, do you see significant disadvantages to doing it?
I don't have any performance numbers, so I don't want to say it is certainly going to be slower. But my gut feeling is if it is a transactional system, it is probably going to be slower than raw file system access. There's also the issue that with raw file system access, you can do interesting things like just read subsections of your textures for LOD schemes.
Great, thanks.
Oh, come on, Seth.
Hi, Rachel. I'd like to hear a little bit more about your thought process around the PC game industry, in that there's a tremendous amount of variability there as well. Somebody could be running on a 46SX something or a Pentium, 16 core. And we've heard a couple of speakers this conference talk about the variability in at least just pure performance on the web, I think, as a direct reflection of the wide variety of machines. I think the PC industry, or at least PC games, have come up with some solutions, or at least they've attacked the problem certain ways. Minimum specs, for instance, and I know that you kind of advocate here for being able to detect some of these hardware features. Just can you expound a little bit on that idea of looking at the full range of potential devices and saying, well, this game actually needs this to run, and it seems like the PC industry did that okay, and can we use that model on the web as well?
I think we can somewhat move to it. I don't think we can do it like the PC industry, where they say, okay, you need actually a 586 with 8 megs of RAM and at least this kind of graphics card, because the amount of devices is just so vast that this is pointless. There might be phones that run faster than some of the computers I have in my home. So what I see as minimum specs for games is probably more tending towards running sort of a micro benchmark on your machine, saying I have this CPU performance, this GPU performance, I support those GPU features, and then you'll be able to find out, does this game actually work for me? I don't think there's something where you can say, any machine you bought after 2012 will run this game.
Thanks.
All done?
Okay, thank you very much.
My pleasure.